Today's lesson is on rectangles, rhombuses, and squares. And guess what? These are all actually parallelograms, so they're just a more specific type of parallelogram. So really just another lesson on parallelograms, and let's see what our learning target is. It says, I will use properties of rectangles, rhombuses, and squares to solve problems involving quadrilaterals. And of course, we're probably going to have some theorems that are going to teach us what those properties are. So here we go. I'm going to start with some definitions. A parallelogram with four congruent sides is a rhombus. You might have been thinking square, but that is the definition of a rhombus. A parallelogram with four right angles is a rectangle. And a parallelogram with four congruent sides and four right angles. So in other words, if it has the properties of both of these, then that is a square. Okay, so now let's take our theorems. If a parallelogram is a rhombus, then its diagonals will be perpendicular. Okay, so let me just draw us. We usually think of a rhombus looking like this. I don't know why we draw it kind of slanted over. It doesn't have to be, because it could be a square, right? But we're going to draw it this way. So there's our rhombus. If this is a rhombus, then when I draw these diagonals in here, they will always be perpendicular. All right, also, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So since we know this is a rhombus, I don't know why my pen isn't working very well, then I know that each diagonal bisects a pair of opposite angles. And why have I drawn these, let's say this angle and this one, to be congruent to this one and this one? Do you remember why I've done that? Oh, because it's a parallelogram, so I know that those opposite angles are congruent. Therefore, if they're both bisected, then I know all four of those angles will be congruent. Okay, if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so let's see our example here. What are the measures of the numbered angles in rhombus PQRS? Okay, it's a rhombus, therefore we know that the opposite angles are bisected. So first of all, I know that angle, I'm just going to write down all the things we know here. I know that angle QPS is congruent to angle QRS. And how do I know that? Because I know it's a rhombus, which means I know it's a parallelogram. Okay, now I know, since I know that it's a rhombus, I know that diagonal PR bisects those two angles. So I know that angle 1 is congruent to angle 2, and that's congruent to angle 3, and that's congruent to angle 4. All four of those are congruent. So how am I going to figure out what they measure? Well, how about this? Let's go back to the fact that it's a parallelogram. Because it's a parallelogram, I know that consecutive angles are supplementary, right? So if the measure of angle Q is 104, then I know that the measure of angle P, which I already said, I probably shouldn't call it the measure of angle P. I shouldn't call it P. I want to name it like I did up above. The measure of angle QPS is 180 minus 104, right? Which is 76 degrees. And this is also the measure of angle QRS, just like we said above. So what do we got to do now? We got to divide that in two. So the measure of angle 1 is 76 divided by 2, which is 38. And that's also the measure of angle 2, angle 3, and angle 4. All right. So now what do we got? Conditions for rhombuses, rectangles, and squares. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. That's actually the converse of the theorem up above. And the next theorem says if one diagonal of a parallelogram bisects a pair of opposite angles, so it's a parallelogram, so if that bisects that angle over there, then the parallelogram is a rhombus. So I know it's a rhombus even if I only know that one diagonal bisects one pair of opposite angles. If I drew in this diagonal, I know that it also bisects these opposite angles, but I don't have to know that both of them do that. I only have to know that one pair of opposite angles is bisected. And finally, the last theorem we're going to talk about here today says if the diagonals of a parallelogram are congruent, then we know that parallelogram is a rectangle, right? That's the converse. That's also the converse of one of the theorems up above. Now look at this. If a parallelogram is both a rectangle and a rhombus, then it is a square. So think about it like this. Let's say we got our rectangle here. We got our rhombus here. I'm just going to call that RH. And let's suppose they got together and had a little baby. It would be a square. So the love child of the rectangle and the rhombus is a square. So think about it. All the properties that a rectangle has, a square has. All the properties that a rhombus has, a square has. So a square is always a rhombus, a square is always a rectangle, but not the other way around, right? A rectangle isn't always a square and a rhombus isn't always a square. Okay, boy, this is going to lend itself very well to some great sometimes, always, never questions. Let's see, I think all we have left now is to do some practice. That's right, so let's do it. Can you conclude that the parallelogram is a rhombus, rectangle, or a square? Explain. Okay, this is probably a good time for me to tell you that on your upcoming quiz or your upcoming tests, I'll probably be asking you to give me the most specific classification of quadrilateral that you can. So this is going to be good practice for us here. So let's see, what do we know? We know, okay, they're telling us that each one of these is a parallelogram. And this picture is telling me that one pair of opposite angles is bisected. So I know that's a rhombus because of the theorem I just learned. If I go back up here, it tells me if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. That's the theorem I used right there. Okay, let's see what we have here. I know the diagonals are congruent, so I know it's a rectangle, right? That tells me it's a rectangle. I know the diagonals are perpendicular. That tells me it's a rhombus. So remember, if it's a rhombus and a rectangle, and it's got to be a square. So just looking at that picture, I also know that all these sides are congruent too, right? Because I know it's a rhombus and I know it's a square. Okay, how about these? For what value of x is the figure the given special parallelogram? So for what value of x is this first one here a rectangle? Well, what do I know? A rectangle has 4 right angles, so I know that 5x plus 2 plus 3x has to be 90. So I know that 8x has to be 90 minus 2, or 88. So I know that x has to be 11 for that to be a rectangle. Why don't you stop here and do these next two? Actually, you know what? I don't think you need me for any of the rest of these, because the next ones are some great, sometimes, always, never. I want you to give those a shot. And of course, I'm going to put the answers up here and talk through it with you. But you pause right here and do these next few problems to the end, and then we'll check. Okay, let's see what we got here. We did the first one. I think I did, right? Yeah, I think I did those two up there, and then number 1, the rectangle. So number 2 here, how do we know what value of x what value x has to have for this to be a rhombus? Well, let's look at this angle here. this angle here, and this angle here. I know they're supplementary, right? Because I know a rhombus is a parallelogram. So I also know that because it's a rhombus, the diagonals bisect those two angles that I have marked. So each piece of it, so in other words, if this little piece right here is 3x minus 6, then that little, plus 6, then that little piece is 3x plus 6 because the diagonals bisect the angles of a rhombus. So I know that 2 times 3x plus 6 plus 2 times 8x plus 7 has to be 180 because those angles are supplementary. And then I just combined my like terms, and I had to actually come over here because I ran out of room, and I ended up with x equals 7. Okay, and then finally on this third one, what does x have to be so that this is a rectangle? Well, look, this is a parallelogram. Diagonals bisect each other, but because it's a rectangle, the diagonals are congruent. So I know that all 4 of these pieces are congruent, which tells me if I look right here at that little triangle, I don't know if I wanted to do that, but anyway, that's what I did. If I look at that little triangle right there, let me draw around it in green, this triangle. See how I've got congruent sides here? So by the base angles theorem, I know that these two angles that they're asking for are also congruent. So I just set them equal to each other, solved it, got x equals 16. All right, now for my sometimes, always, never questions. A square is a rectangle. A square is always a rectangle, remember? Because a square is always either one of its parents. A square is always a rhombus. A square is always a rectangle. A rectangle is a square. Well, only sometimes is a rectangle a square, because a rectangle doesn't always have congruent sides, right? Okay, a rhombus is a square. Again, sometimes, right? Because the rhombus doesn't have to have right angles, but a square does. Okay, number 4, a parallelogram is a rectangle. Sometimes it is, but a parallelogram, of course, does not have to be a rectangle. Number 5, the diagonals of a rhombus are congruent. Sometimes. When would the diagonals of a rhombus be congruent? When it's a rectangle, right? A rhombus can be a rectangle, right? If it's a square, it's a rectangle. So sometimes. If you're getting confused by this, don't worry. I got plenty of practice for you to do in the classroom. Okay, number 6 says the diagonals of a square are perpendicular. That would be always, right? Because the diagonals of a rhombus are perpendicular and all squares are rhombuses. So that's got to be always. Number 7, each diagonal of a rectangle bisects a pair of opposite angles. Sometimes, right? Because a rectangle could be a square and a square is a rhombus. So each diagonal of a square bisects a pair of opposite angles. So therefore, if the rectangle is a square, that would be a true statement. Okay, number 8, the sum of the measures of the interior angles of any quadrilateral is 360. That's always, that doesn't even have anything to do with parallelograms. That's just using the formula n minus 2 times 180. And of course, n is 4 in the case of a quadrilateral, so 2 times 180 is 360. Number 9, the diagonals of a parallelogram are congruent. That's sometimes. When the parallelogram is a rectangle or a square, the diagonals are congruent, but only during those times. Number 10, the diagonals of a rhombus bisect each other. Always, right? Because a rhombus is always a parallelogram, and the diagonals of a parallelogram, every parallelogram, bisect each other. And finally, a quadrilateral with perpendicular diagonals is a rhombus. That's always, right? We had a theorem that told us that if a quadrilateral is a rhombus, then its diagonals are perpendicular. Okay, so that's it for rectangles, rhombuses, and squares. Be sure to write a summary. Be sure that you've made flashcards for all these theorems and you you study them so that you don't get your properties of all these different parallelograms mixed up. See you next time.